Hello again, Mr. Keller. This is David Engell doing quiz number 48. And on this first question, I'm going to solve it using some energies. So you start out with 1/2, oh come on pen, don't die on me, 1/2 I omega squared plus 1/2 mv squared equals mgh to find the height eventually. So what you gotta remember here is that you're gonna have 1/2 and your I is gonna be 1/2 because it's a disk, mr squared, and your omega, since it's moving linearly, is going to be v over r squared. And that added to the 1/2 mv squared is going to equal mgh. So it's all of this niceness over mg, forgot the h over there, equals h. So hooray! 1/2 mr squared over v over r squared plus 1/2 mv squared over mg equals h. And the distance it travels along the incline, since we've now found h, it's going to be, you can draw this nice triangle here with this as your theta, this is your incline x, this is your h, and x, the distance up, is going to be h over sine theta. I would write h out for you again, but I'm lacking in room, and it's right here. I mean, you can plug it in for that if you want, but I mean, you know I can rewrite it, but I just didn't. I'm sorry. Please don't hate me. The acceleration, what we're gonna do is we're gonna use our VF equation, since it starts out. Since it's at 0 when at final velocity, we're going to set that equal to vi squared plus 2a delta s, and we're going to set delta s equal to h over sine theta. So when you rearrange, it's going to be vi squared times sine theta over 2 equals a. That's going to be your acceleration. Number two, again with some energies. Starts with gravitational potential, mgh. That is going to be equal to the kinetic energy that the block has when it hits the ground, mv 1/2 mv squared, plus the rotational kinetic energy of the system, 1/2 I omega squared. Again, remembering that I is going to be, oh well, I'll write that for you later, but remembering that omega is going to be v over r, and that whole thing squared. And so what you're going to end up with is mgh equals, oh, I'm probably not going to fit it. This is going to be bad. It's going to be okay though. Equals 1/2 mv squared, that quantity, plus, oh no, the rotational kinetic energy is going to be a tight squeeze, but 1/2 m1 r1. I know the camera probably sucks and can't pick this up, but yeah, it can't. I'm looking at it right now. That stinks. But sorry, plus 1/2 m2 r2 squared times v squared over r squared. And then what's that? That's going to be equal to mgh. And basically you're going to pull out the v's, the v squareds, and that's going to equal that whole thing, mgh divided by that whole thing. So it's going to be 1/2 m plus 1/2 m1 r1 squared plus 1/2 m2 r2 squared times r2 squared. And since it's v squared, we're going to cancel that v and square root this whole side. and that's going to be what our V is going to be equal to. And then by doing that, we can just basically swing this V value, this huge thing, where you can just swing it down, and our omega of the large disk is going to be that over R1. And again, I would rewrite it for you, but you said today I didn't have to. So that is quiz number 48, all in all its glory. So you're welcome.